Hello everyone, this is Mohammad Saib Nambar Prohor back again with another video. So today I'm going to talk about Scikit-Learn. So Scikit-Learn is a machine learning library. It is used for simple and efficient tools for predictive data analysis, accessible to everybody and reusable in various contexts. It is built on NumPy, SciPy and Matplotlib, and it's also open source and commercially usable. So it is used for classification, regression, clustering, dimensionality reduction, model selection, preprocessing, etc. And it has a very large community, and because of that, we can get new algorithms day by day. It also has its own API, and there are various examples of scikit-learn. As you can see, that there are various navigating tools and datasets of scikit-learn. So today we are learn about some of the basics from scikit-learn. So let's move on to the coding. So as I said earlier, that Scikit-Learn is an open source Python library used to perform machine learning. It provides a range of supervised and unsupervised learning algos. It is generally used for fit and predict estimators, transformers and preprocessors, pipelines, model evaluation, automated parameter search. It also contains packages like NumPy, Matplotlib, and SciPy. SciPy is scientific Python and one of the most popular library used worldwide. And it also has good documentation and wide adaptation across industry and academia. So it is also used for various research and various industry level products. So at first, we're going to see how to install Scikit-Learn, if not already installed. So we will use pip install Scikit-Learn and run it, and it will run through our Windows and check if it's installed or not. So requirement already satisfied in my device, but you can install but just by writing pip install Scikit-Learn in your command prompt. Moving on, we will import sklearn, which is Scikit-Learn in short, and now we will check the version. To check the version, simply just write sklearn dot underscore underscore version underscore underscore, and my version is 1.2.2, which is the latest version. So we'll import our important libraries, which is NumPy as np. Then from Scikit-Learn, I will import the iris dataset, then test train split, which is used to split the dataset into training and testing sets. In my machine learning videos, I said earlier that we split data into two sets, with one for training and one for testing. So we use Scikit-Learn to split the data. Now, k-neighbor classifier, in which implements the k-nearest neighbors classifier, and accuracy score. Accuracy score computes the accuracy of the classifier. So we are gonna implement our algo on the iris dataset. So we are gonna load the iris dataset. Now we are gonna extract the features into X and target labels into Y. So we are gonna write iris equal to load iris. So by using load iris function, we are gonna load the data of the iris dataset and we'll move the data to X and target to Y. Let's run the code. Now, as we splitted the dataset into training and test sets, we'll use 80% for training and 20% for testing. And random state parameter ensures reproducibility. So we're gonna put our train into X train and Y train and test the data in X test and Y test. So as you can see, that test size is 0.2, which is 20%, and 80% split around by X and Y. Let's run the X10 Y10. Then we'll initialize the k nearest neighbor classifier algorithm. So neighbors are n neighbors are 3, meaning it will consider 3 nearest neighbor for classification. Now we will use knn or k neighbor classifier, and the n is 3. As I said earlier, that we will consider 3 nearest neighbors for the classification. And let's run the code. Then we'll train the classifier and we will feed the training data into the KNN. Let's run it. And now the classifier is training on the iris dataset which we split earlier, and the training is going on. It takes some time, but it will end eventually. Okay, so let's move on to our prediction on the testing set. Then for our Y prediction, it is the predict function we will run on the testing dataset of X. So after finishing the training, it will move on to the prediction of Y. So let's run over here and calculate the accuracy of the classifier. So right now our classifier is being trained, while we will put the testing dataset in the prediction score of Y prediction. It helps us to compare the train data and test data. And to bring out the accuracy, we will just compare Y test and Y prediction, and by using the accuracy score function, it will give us a perfect score, or the score it shows by mathematical calculation. Okay, it's still running. Yeah, the training is done. As you can see, the n neighbors is equal to 3, and now it is predicting the prediction on test dataset of X. We'll come back it on later. I think there are some issues. Okay, so the usage are fit and predict estimators. Scikit-Learn provides dozens of built-in learning algos and model called estimators. Each estimator can be fitted into some data using its fit method. Now, each estimator has two methods. One is fit and one is predict. So from scale-learn linear model, we'll import linear regression. Then we'll create our estimator linear by using the linear regression function, and we will feed our data set into the estimator, and then we will use the predict function to bring out the prediction of the new data. Now moving on to transform and preprocess. Transformers are like machine that transform the data into different form, and preprocessors are the transformers that get the data ready for the machine to learn from. So as you can see that I have used a picture of a pillar, and transformers are like that. It is a pillar which change the form of the data, and then preprocessors are the transformers, or the data that change, that machine can learn from. As you can see, the accuracy is 1, which is perfect score. So yeah, I was talking about transformers and preprocessors. So moving on, let's say I have a sample text data for demonstration, which is for training dataset. I say I like sandwiches, I love tomatoes, and sandwiches are tasty. And for testing data, I enjoy sandwiches. I then tomatoes are very healthy. So these are some similar lines, but they are not exactly the same. So we can see if the data or predictor works nicely on this data. So then we are going to use a preprocessor or transformer, so which is called count vectorizer. Then feed the preprocessor to the training data, then transform the text data into numbers. So the machine doesn't understand the text, so it will transform this data into the numbers, and then it will run the algo or train the algo. So then transforming the data by using the fit transform, and then pre-processing the data into the transformer. Now moving on, the pipeline. So pipeline connects the preprocessor and the estimator. So we'll import sklearn.pipeline. Then from sklearn.preprocessing we'll import standard scalar, which we use for scaling, and then from sklearn.svm we'll import support vector machine. Then we'll create the pipeline, which is standard scalar and support vector machine for the preprocessing estimator. Then we'll feed the pipeline to the data and make predictions. Now, as you can see that we have fit the training data from X and Y, and then we predict the data using the model. Now, to evaluate the model, we will run our accuracy score. Now, let's say, as you can see, our accuracy score is perfect 1. Perfect 1. Then we will use sklearn.model selection and then import grid search CV. So our parameters are C 0110 and gamma 0.001, 0.01 and 0.1, which is decreasing by 10 to the power 1 or 10. And grid search will be run on SVC as well as the parameters I have set. Now for grid search, we will feed the data here and then we will see the score. As you can see, our C is 1 and gamma is 0.1. So these are some of the basics of Scikit-Learn, and I have used the iris dataset to teach you the basic parameters. So if you want to use the Scikit-Learn for your machine learning algos, you can use the documentation here, and here are various documentation like classification, clustering, covariance estimation, cross decomposition, dataset examples. We have division trees, decomposition, developing estimators, Gaussian mixture models. Also, we have also kernel approximation, then model selection, neural networks, nearest neighbors that I used in this model, then semi-supervised classification. So Scikit-Learn is a very versatile and very useful ML library, also open source. And this was the basic video for it. Thanks for staying with me.